Welcome to our second lesson on organic chemistry. Specifically, in this lesson, we'll be talking about hydrocarbons. So just relax and pay very close attention as we discuss this topic. It will be a very, very short lesson. We didn't go too detailed into it. And in some few minutes, we should be done with the focus of today. So stay tuned as we discuss the topic. Hydrocarbons. Hydrocarbons are basically organic compounds that contain carbon and hydrogen only. Carbon and hydrogen are the only two atoms present in hydrocarbons. And all the hydrocarbons that exist in nature can be grouped into four. We have alkynes, and aromatic hydrocarbons. For the alkanes, the carbon atoms have only single bond between them, something like this. So alkanes are hydrocarbons in which the bond between the carbon atoms are only single bonds. For alkenes, the bond between the carbon atom should be double, at least. It doesn't mean all the bonds should be double like this. No, that is not what it necessarily means. At least you should have one double bond between the carbon atoms. We can have this, it's an alkene. We can also have this. We can have maybe two double bonds at different places in the alkene. Something like this is also an alkene. Then for the alkynes, there should be a triple bond between the carbon atoms in this way. There should be a triple bond between the carbon atoms. For the aromatic hydrocarbons, they are the hydrocarbons that form rings. And the simplest form is the benzene ring. The benzene ring is the simplest aromatic hydrocarbon. I think something like this. So we have 1, 2, 3, 4, 5, 6. This is a benzene ring with alternating double bonds. Whereas the double bonds are alternating. We have a double bond, a single bond, a double bond, a single bond, a double bond, a single bond. So this is a benzene ring. There are other types of aromatic hydrocarbons as well, like the naphthalene. So you can check them out and see how the structures look like. So these are the four main groups into which organic hydrocarbons are classified into. So in subsequent videos, we'll pick them one after the other. We'll pick the alkenes and discuss them. Maybe in this video, we'll discuss the alkenes. And if there is time, we will discuss the alkane. And if there is time, we'll go on and discuss alkenes and alkynes. So it depends on how long the video will be. Now, these form groups of hydrocarbons can be put into two main classes. And the class to which these hydrocarbons belong to depends on the the nature of bond it has, either it being a single bond or a double bond. And the first class is saturated hydrocarbons. So these four hydrocarbons we mentioned earlier in the slide can belong to either a saturated hydrocarbon or an unsaturated hydrocarbon. For the saturated hydrocarbons, they are the hydrocarbons in which the carbon atoms contain only single covalent bonds. The carbon atoms have only single covalent bond, and these are the alkenes. If you remember earlier, these are the alkenes. So there is only single bond between the carbon atoms, and alkanes are the only hydrocarbons that are saturated. A specific example of an alkane, let's pick something like this. So that means there will be hydrogen here because it's a hydrocarbon. There will be hydrogen here. another hydrogen, another hydrogen over here. It takes time, yes. You have to, even your final exams, you have to take time and write each of these. If you are to write the structure in this form, you have to indicate the hydrogen. So you realize that a hydrocarbon having only carbon and hydrogen, as we stated earlier. So this is a saturated hydrocarbon because each of, let me number the carbons, the first, second, third, and fourth carbon. Each of these carbons here has 4 bonds, only single bonds. All the bonds are single bonds. That makes it a saturated hydrocarbon. And saturated hydrocarbons undergo substitution reaction. Keep that in mind. It undergoes substitution reaction when it gets to the chemical property of these hydrocarbons. So hydrocarbons, these saturated hydrocarbons undergo substitution reaction. And for substitution reaction, we are just referring to removing one of these hydrogen and replacing it with a different atom. That's basically what it is. We'll actually be talking about it later, but spoilers alert, just keep it in mind. It's just removing one of these hydrogens and replacing it with a different atom. For example, you can remove this hydrogen here and will be replaced with maybe a bromine. You can remove this one and replace with a chlorine. So this is just a substitution reaction, removing one of the atoms and replacing it with a different atom. These are halogens. So basically, this substitution reaction is basically halogenation. Good. So what that also means is that immediately we replace this hydrogen or bromine or chlorine here, it's no more a hydrocarbon. It's an alkane, all right, but it's not a hydrocarbon because you realize that chlorine here is not a hydrogen and bromine is neither a hydrogen. So it's a haloalkane. Yes, something that we'll talk much about it in subsequent videos. Now, for the unsaturated hydrocarbons, they are basically those hydrocarbons that contain either a double or a triple bond. And the double or triple covalent bonds are known as the multiple bonds. So, unsaturated hydrocarbons have multiple bonds between them. And these are the alkenes and alkynes. They are the simplest, so basic unsaturated hydrocarbons that we know. And they undergo addition reaction. So, alkenes and alkynes are unsaturated hydrocarbons. Let me pick one specific example and see. So this is an alkene. So let me put a double bond here, and then since it's a hydrocarbon, let's fill it out the remaining side with hydrogen. We would pick each of the alkanes, alkynes, more into detail in subsequent videos. And when we get there, we'll look at how to draw the structure and explain it into detail. So for now, just don't worry too much about it. So there's only one hydrogen here and another hydrogen here and this. So this is an alkene. Why? Because of the presence of the double bond over here. So the double bond you see over here makes it an alkene. And therefore it's an unsaturated hydrocarbon. Another unsaturated hydrocarbon is the alkyne. So let me pick 1, 2, 3, 4. Let me just use this one. Let's say we have a triple bond here. So this will have hydrogens around it. Same applies to this. So this 1, 2, 3, no hydrogen here, no hydrogen here. Then we have hydrogen here. Don't worry, I will teach you how to draw the structure and how to name each of them in later videos. So the presence of the double or the triple bond here makes alkenes and alkynes unsaturated hydrocarbons. And they do not undergo substitution reaction, but rather addition reaction. So you can add an extra hydrogen to an alkene or an alkyne. Or you can even add not hydrogen, but maybe a halogen, more in halogenation as we spoke about in the alkenes. So for the addition reaction, one of these bonds is going to be broken if we have to add it to the alkene. So this bond can be broken. Yeah, let me just put it that way. So here there will now be only just, let me use an eraser. So let me get the eraser. So eraser. If it is addition reaction, that means we are going to remove this, and now we have one bond here. And then what happens is that uh, it now becomes this way. So we have pen. So the one bond that has been broken there now becomes this. So we've added more hydrogen. So realize that the addition reaction has changed this alkene into an alkane. That's basically what it is. It has changed the alkene into an alkane. So this is an addition reaction. And the same addition reaction can go on over here in the alkynes as well. Let's say we have three bonds here, 1, 2, 3. The first two are stacked on top of each other. So these two bonds can be broken and hydrogen should be added. So I think that is enough for the alkenes and the alkynes. But take note of this. Although in your textbooks, perhaps when you are asked to mention unsaturated hydrocarbons, the basic examples you normally see are the alkenes and the alkynes. Take note that aromatic hydrocarbons also have these double bonds in there, so they are also a type of unsaturated hydrocarbon. So let's say something like this. I think we drew something earlier, benzene. So this, excuse my drawing. So alternating double bond. So this double bond here makes it an unsaturated hydrocarbon. But one interesting thing is in your literatures, you would realize that the textbook you use at your level do not add this as unsaturated hydrocarbons, but they fall under that. But one interesting thing about the benzene rings or the aromatic hydrocarbons are that they are very stable as compared to the traditional unsaturated hydrocarbons, alkenes and alkynes. They are very stable and do not or are resistant to addition reactions. They are very resistant to addition reactions, but they also have, we can put them under the unsaturated hydrocarbons group. So I think this is enough for this video. Just make sure you understand this basic introduction lesson to the hydrocarbons. In the next video, we'll talk much about case. So come back for the next video.